Hi everyone. I unfortunately have to be gone today, but we're going to continue on regardless. We are on the second part of chapter 6, which is on solving systems of equations, and today is kind of a synthesis summary day. So that's good and nothing super new. We're just kind of summarizing everything that we've learned. You need your note packets out to section 6.5. There shouldn't be any homework to go over. So if we need to pause the video in order to make sure everyone has their note packet out, go ahead and do so. Otherwise, I'm going to assume that we're good to go. So as I said, the whole chapter's involved one question: where do two lines cross? And there are three skills that enable us to answer that question. The first one is you can graph and try to find where two lines cross. You can use substitution. And then the last one is elimination. There's a variety of types of elimination, but they all involve eliminating one of the variables to get rid of one of them and then solve for the other. So there's three tools. Today we're going to talk about when is it best to use each one, and then practice identifying and using each of them. And yeah, so first tool that we use this chapter is graphing. Graphing, this is what the book says, and I'll give you my personal preference. Graphing, they say, is best to estimate solutions, since graphing usually does not give an exact solution. So graphing's good to kind of get a start. If the numbers are small and you're sure that it's going to cross at an intersection, then graphing might not be a bad idea. However, if there's any chance that the answer could be a decimal or you involved large numbers, graphing is not going to be an adequate tool. So graphing is really just kind of the first way to understand the concept, but it's not going to be really used to be an exact process. Tool number two is substitution. Substitution is excellent if one of the variables has either a 1 or a negative and 1 in front of it, meaning it's easy to get one of the variables by itself. Because in order to substitute, you need one of the variables by itself. So in order to substitute, the book says if you have a coefficient of 1 or negative 1, meaning the number in front of the variable is either a 1 or a negative 1, and it's easy to get that variable by itself, then use substitution. Tool 3 comes in a variety of different forms. You can do elimination using addition, subtraction, or you might need to multiply. They say elimination using addition is good if you have variables that have opposite signs from one another, if one's positive and one's negative. Subtraction will be good if the variables have the same sign. So if they're both positive or both negative. So you use addition if they're opposite signs. You would use subtraction if they're the same sign. Multiplication is used when all other tools fail. So if none of the coefficients are a 1 or a negative 1 and neither of the variables can be eliminated by simply adding or subtracting, you might need to use multiplication to get them matched up. So elimination using multiplication is kind of your last tool because it involves probably the most amount of steps. So those are tools: graphing, substitution, elimination. With those definitions, we're going to practice looking at a variety of systems of equations and talking about which one would be best for each case. So here we go. I have the ability to move these. You might want to just put a G, an S, or an E next to them in your note packet or draw arrows, whatever you like. But let's start. So let's go with maybe like an easy one to start. So this has y equals 2x minus 8 and 3x plus 4y equals 12. This would be an example of substitution. Y is already solved for. You can easily substitute y into the other equation. That is substitution. So look at this one. Right here, none of the variables can be easily solved for, and if I look, my y's are already matched up. They're opposite signs, so if I add the two equations, my y's will get canceled out, so I can easily eliminate for this one. What about this guy right here? If I look, none of the coefficients are a 1 or a negative 1. None of them match up. So this one's going to be elimination by multiplication. So you would do elimination by multiplication for that one. What about this guy? Y equals 2x minus 3 and y equals 3x plus 4. So there's two things. This looks like a typical graphing one since both of them have nice slopes and y-intercepts. You could also do substitution. You could take 2x minus 3 and substitute it down here into the bottom left for that y. So I would say graphing or substitution would be fine. I think the book is going to call that one graphing. What about this guy? This kind of is similar to the one we just did, right? They both have nice y equals mx plus b forms, so you can easily graph them. You could also do substitution. You would take 1/2 x minus 5, substitute it down below, and set the two equations equal to one another and solve. So either graphing or substitution, which means this last one has to be substitution. Why is it substitution? You already know what y is. Y is equal to 5. You can just substitute that down below and easily solve for x. So that might be one of the easiest ones that we've looked at all chapter. So there's an example of 2 for graphing, 2 for substitution, and 2 for elimination. With that said, now we're going to start to apply it. We're going to look at a problem, identify which tool is probably the best to use, and then go about solving with that method. So this one, I would say there's probably 2 tools you could justifiably use. You could do substitution because you could easily get this y all by itself. If you did that, you would add the 8x over to the other side, 19 plus 8x, and then you would take this piece right here and you would substitute it into that y in the other equation. So you could easily do substitution. If that fits your fancy, then go ahead and do that. I'm going to show elimination just to show a different technique. But if you want to do substitution, that'd be just as justified here. So if I wanted to do elimination, I would need to either match up my x's or my y's. I'm going to match up my x's. So if I want my x's to match up, this top equation, everything needs to be multiplied by 2. So we multiply the left side by 2 and the right side by 2. So my new equation for the top is going to be 8x minus 8y equals 16. The bottom equation doesn't need to be altered because my x's already match up now. Plus 1y equals 19. If I look, I have opposite signs, so I'm going to add the 2 equations. Now the x's go away. Negative 8y plus 1y is negative 7y equals 16 plus 19 is 35. Then I divide by a negative 7 and I'll get y is negative 5. Once I have y is negative 5, I need to substitute back into one of the original equations. It doesn't matter which one. I'll drop it in right here. I'll put negative 5 right in there for y and solve for x. So I have negative 8x minus 5 equals 19. Add 5 over the other side, and I get negative 8x equals 24. Divide by a negative 8, and I have x equals negative 3. And then make sure to answer the final question. You're trying to find where 2 lines cross. You need to describe your answer as a point. That point should be negative 3 comma negative 5. So there's an example. I did it by elimination. You could justifiably easily do it as substitution as well. So there we go. I'm going to give you a chance to try. So pull out your whiteboards, determine the best method to solve, and then go ahead and do it. So give it a go and unpause the video once everyone's had a chance to try. Okay. This one's definitely elimination. So the reason why is because both of the x's match up. If you add the 2 equations, 3x plus negative 3x, those will go away. I end up with negative 4y's plus 2y's is negative 2y's. Negative 5 plus negative 5 plus 3 will be negative 2. If I divide both sides by a negative 2, I get y equals 1. Once I have y equals 1, I can substitute it into either of the original equations. I'll do the top one. So the top one then becomes 3x minus 4 times 1 equals negative 5. That leaves me with 3x minus 4 equals negative 5. If I do that right? Yep, looks good. If I add the 4 over the other side, I get 3x equals negative 1. If I divide both sides by 3, I get negative 1/3. So we can check it. If you put in negative 1/3 here, negative 3 times negative 1/3 is going to be a positive 1. Positive 1 plus 2 is going to be 3. So it checks out. So my answer looks to be negative 1/3 for x, positive 1 for y. And there you go. So there's that one. Last one we're going to practice is doing a word problem one. So this one says to raise money for a field trip, the French club sold pizza and subs at a basketball game. They sold 11 more subs than pizzas and earned a total of $233. Write and solve a system of equations and interpret the solution in context. So let's say x is equal to the number of pizzas and y is equal to the number of subs. The first thing that they told me is they sold 11 more subs than pizzas. So that means subs is equal to pizzas plus 11. Second piece of information, so this is kind of the red piece. Second piece of information they said is they earned a total of $233. So that's my cost equation that I told you always exists. Well, pizzas were $5, so $5 for every pizza, plus $3 for every sub has to total $233. Now I have my 2 equations I need to solve. This is an example of substitution because you can easily get y solved for. Just like probably the best tool would have been substitution if I were really to think back and go through this one. But you can do elimination as well because you can easily get y solved for. So this one right here is definitely substitution. I'm going to take y equals x plus 11 and substitute it right in down below. So this second equation now becomes 5x plus 3. Instead of writing y, I'm going to write x plus 11 now equals 233. Now solve. Distribute first, you get 3x plus 33 equals 233. Subtract the 33, I get 8x equals 200. Divide by 8, and that leaves me with 25. So the number of pizzas that they sold was 25. If I know that, I can easily find the subs because they said they sold 11 more subs. So add 11 to it, and I will find that they sold 36 subs and 11 pizzas. So an example of setting up and solving a word problem system of equations question. Going to give you a chance to try one very similar to that. Here's your question. It says, two students, Mara and Ling, each recycled cans and newspapers as shown in the table. Mara earns $3.77 and Ling earns $4.65. It tells you how much each of them recycled. So Mara did 9 aluminum cans and 26 newspapers. Ling did 9 aluminum cans and 114 newspapers. Can you define some variables and then write a system of equations for the situation? So maybe I'll help you with the variables part. You could say x is equal to number of cans. You could even use c if you want to. Y is equal to number of newspapers. Now, can you write a system and solve that system based on the information given? So pause the video now, give yourself a chance to try. Unpause it maybe after 2 minutes and everyone's had a chance to try and see how they did. Okay, going over it, here's the two equations you should have got. It said Mara did 9 cans plus 26 newspapers, and she was given $3.77 for her total. Ling did 9 cans and 114 newspapers and was given $4.65 for his total, so $4.65. This is a perfect example of elimination because your x is already matched up. They have the same sign, so I'm going to subtract. 9x minus 9x is going to give me 0. When I subtract the y's, I get negative 88 y's. When I subtract the dollar amounts, I end up getting negative 0.88. If I then divide, I find that y is 1 cent. And that was actually the question. The question is, what is the value of 1 pound of newspaper? And y was, oh, sorry, not numbers. That was my bad. This should have been pounds. Same with this one. This would have been pounds of cans. So not number of cans, but pounds of cans. So each pound is valued at 1 cent. So there you go. That is it for today. The homework questions come from section 6.5. The answers are right here. You can check your work as you go if you leave the video paused, and then have questions ready for me when I return. Thank you very much and have a good day.